In the era of the generative AI, when it comes to deployment of the large language models or any other generative AI systems, you would inevitably deal with the handling of the streaming data. And in this video, I'm going to demonstrate you the most minimalistic approach when it comes to integration of the large language models or any other streaming-based services into the web world. So with that, I mean, we're going to use the pure JS as a one part of the video. And in the second part, we're going to combine it with the manually implemented proxy services. This is specifically not contributes to the minimalistic part because this choice would be up to you. But in this video, we're going to use the FastAPI service. This video is organized and based on the snippets that are represented in my personal account on the GitHub gist. So one of them, and at the moment on the slide, on the web page, you can see two of them. So one overview is the streaming LLM replicate API, which involves a streaming purely based on one particular service. And then we'll take a look onto another implementation that involves the proxy server, which is, I must mention it, this assumes to be the FastAPI. All right, so we're gonna start this video by overlooking the most minimalistic approach, which is purely based on JS, and it assumes to be integrated for the replicate AI. So this is the snippet that we're going to use in our project. So let me just quickly showcase you how it is organized in the sense of the concepts that represents the streaming. So the whole script first launches the functional handle SSE, which has the API URL to the service on the replicate platform. It provides the accompanies with the request body, which has the prompt message that we're going to ask and receiving streaming data. And finally, we just iterate with the results by outputting the content. So the main function, it is based on the SSE stream iterator, represents the post-based approach. So that means we're sending the post request and waiting for response from it. On the next step, we receiving the body, and the content of the body is actually represents the reader. Finally, we use this reader in order to extract the content and decoder of the content to receive the actual data. So let's use this code and paste it in a shell and try out to launch. I already did this for us, and this brings me to the console in which I arranged the demo project, which has the JS folder with the related script. If we take a look, so this is the streaming LLM replicate API JS. Once it's going to be opened, so this is again exactly the same file. The only difference is that I paste the bearer code and to replicate key in particular that we're going to use for this video. All right, so once it's there, I'm going to use the node in order to launch this script. So, and unlike the Google Chrome, so this is the way on just purely launch the JS script in the console. So we're going to go node streaming API request. And as we can see, we receive the data that represents chunks from the replicate platform with the different events. So, and as you can see for now, it represents the output that's a part of the message, and it finalizes with the event that seems to be done when we know that's the end of all the messages. Let me just quickly demonstrate you with the diagram on how these concepts works and everything that were mentioned related to the SSE stream iterator function. So this is the diagram that represents the concepts that we already overview. So on first step, we have the post request that we are sending to the third-party provider. Then we have a reader, and once we have reader, we pretend to fetch the data and perform parsing. But and as you may notice here, the main limitation with all of this approach is that our parser is purely dependent and implemented with respect to the conditions the third party is supposed to provide data for us, which is, on another hand, been mentioned in the following post implemented by the Simons-Wilson. You can find it on the web and have a greater detail, but just let me quickly skim through to get an idea on the problem that is raised in this approach. So Simons-Wilson has explored the various ways on how other streaming platforms are working in the sense of the output data they have. So for example, when it comes to OpenAI, with this certain settings, and unlike the replicate, you may have the data that represents the JSON content. When it comes to the Anthropic Cloud, it comes with the different event messages accompanying the data that goes in the JSON. As you may notice, that the content of the event differs from the one that we've seen in replicate. And again, Google Gemini, it represents the JSON tokens that sort of that in the JSON that we receive. So again, we're dealing with the different standards. And also, most importantly to notice that when we bring back to this concept is that here we have a data, it's not JSON, it's an actual textual content, which represents and other issues in the processing, so on. Okay, so, but nonetheless, this is the approach that you can have, and use the script to integrate this in the demo that we will see later on in another format. Let's switch to the second part of the video when and we particularly contribute to the erased problem that we've seen in this diagram, and in particular on how sort of to cope with the parser dependence from the third-party provider. So this brings me to show you another diagram to address on the related problem. We're going to introduce and use the proxy server that represents the standardized version of the content that we pretend to stream to our web. So as you can see now, this part has become universal, and then we have different providers that or adapters that we implement later on for the third-party, various third-party providers, such as that host Gemini AI, OpenAI, Cloud, and any other. Okay, so let's, and that brings me to the second part of the video where I have a specific folder, which is GS FastAPI. Again, so we based our service on the FastAPI in order to deal with it. So this is the Python based framework. So we first have to install the Python environment in order to launch it. So I'm going to start by preparing the environment for it. So we're going to go with the Python to create the virtual environment first. So as you can see, now we have an environment which is going to activate it by going with this. All right, so now we are in environment. Let me just quickly showcase you how the streaming data in that streaming provided data works in that particular case. As you remember, we started our video by analyzing the GIST on the our GitHub GIST account. So within the second part, there is a specific note that's been made here. We have just slightly customized the GS service that, again, based on the post approach. And as you can see, we have, again, the same format as we've seen for the replicate to the handle stream. And then the stream iterator represents the same post-based approach. So we send in the post request, and then we receive the reader. And after that, we use exactly the same decoder to encode the content. While, and most importantly with this node, is that we have the LLM streaming. So this is the FastAPI service. So we're going to use this code in our projects, is what I already made. And in order to launch this, so the dependencies that we have are FastAPI is what we pretend to install. We also have to install the Pydantic for type checkings. So this is going to be necessary later on. And or JSON, which is I'm going to give a comments later in this video. Okay, so to continue with this, we're going to go with the install FastAPI. We also need or JSON. And another thing is that I didn't mention, but we also have to have the service that we use to launch the FastAPI server. This is the UVcorn. Okay, so everything is installed. I'm just going to quickly show you what's the stream data py that is based on the FastAPI looks like. So, and to continue what we've seen earlier, so we've seen this, there's all these dependencies. So the FastAPI service works pretty much straightforward. So we implement the app, we provide the format of the question that we expected to receive from server, and within this particular simple example, instead of handling the question, we just provide the already predefinite set of the chunks that are sent from the server. Then all we have to do, and before actually moving forward, so to better demonstrate you the differences and the way how the chunks will be received in the form of a string way, let me automatically provide the timer in this video. So it brings me back here, and I mindfully put the 1 second delay after receiving of each token. So this is just the dictionary requires to put the component here. All right, so once we created this, so with our next step is that we have to launch the service. For that, I'm prepared the run file, which is run sh. If we take a look on the content of the run sh, we can see that we're using the UVcorn that we previously installed, and this is going to be a service that's going to be run onto the port is 4000. So it's going to start this service. As you can see, it's running onto the HTTP on the local host with the port 4000. And by opening the another terminal, so we're going to go with exact the same folder. All we're going to do is pretend to launch with the node LLM stream post.js. And as you can see, this is the result that we have. So with the delay of the 1 second, we receive the content from the servers, which is this is the streamed response that will be received. Is again is what we see here with the chunks. Okay, finally, let's complete this video with the automatically created the HTML page as the result of the demo. And when it comes to deployment of the platform on the web, so I have preliminarily generated the HTML page, which looks as follows. So to launch this, I need to can proceed with the Google Chrome index HTML. So this is the form which we're going to use to submit the requests, and in the backend it use exactly the script that we has just used for our FastAPI service. We don't temporarily use the prompt content, although we have to type something in here and then the pressed submit button. I believe if we're launching at the moment, we experience with the problem. So you can see that and although the server is launched, we cannot gain access to it. And the problem is that in that particular case, you may see the error of the method is not allowed. The problem again here is that within this service, we have to customize it and cope with the coarse issues by running cross resources on the similar hosting platform. So to cope with that, I have specific line here that we're supposed to put here. Additionally in the script, so we're adding the coarse middleware. Again, we're going to put it somewhere here and also paste the related dependencies. Here we go. So this is how we customize our proxy server that we saved, and then all we have to do is just launch it again. And once we are back to our form, I'm going to submit it again. And now, as you can see, as a result, we have the streamed data. At the moment, we did not output them with the separated spaces, but this is illustrate you on how you can work. So if you submit it again, so we are still will receive the exact the same message. And that's pretty much it for the introduction for this video. In the following videos, we're gonna skim through and find out more on how to actually attach your LLM model, because this template is already there. So you're free to go with your own streaming service that are and will be integrated for that part that we represent here in the form of the chunks. So stay tuned, and I will see you in the next video.